Does the sequence a sub n equals n factorial over e to the 2n converge or diverge? If it converges, what does it converge to? To determine whether a sequence converges or diverges, we must evaluate the limit as n approaches infinity of the general term, n factorial over e to the 2n. If this limit is a real number, then the sequence converges and converges to that number. Otherwise, the sequence diverges. So here, as n approaches infinity, the factorial in the numerator is going to get bigger faster than the exponential in the denominator. So this limit at infinity is going to infinity, which is not a real number, so that means that the sequence diverges. We have the same set of instructions. This time the sequence is a sub n equals 3/4 to the n. So let's evaluate the limit as n approaches infinity of 3/4 to the n. Well, I'm going to rewrite this as the limit as n approaches infinity of 3 to the n over 4 to the n. Both the numerator and denominator are exponential functions, but the exponential in the denominator has a bigger base. So as n approaches infinity, the denominator is growing bigger, faster than the numerator, so the limit is equal to 0. Now, since 0 is a real number, we know that our sequence converges. So our sequence converges, and more than that, we know that the sequence converges to 0. Now, on this example, our sequence a sub n is equal to 2n squared plus n all over 1 minus 4n squared. So we'll set up our limit as n approaches infinity of 2n squared plus n over 1 minus 4n squared. In the numerator, my function is dominated by 2n squared, and the denominator, my function is dominated by negative 4n squared. In this example, our sequence a sub n is 2n squared plus n over 1 minus 4n squared. So we'll set up our limit as n approaches infinity of 2n squared plus n over 1 minus 4n squared. Looking at this limit, the numerator is a polynomial of degree 2. The denominator is a polynomial of degree 2. So we can evaluate this limit by looking at the coefficients of those dominating terms. And so we end up with 2 over negative 4, or negative 1/2, which is a real number. So what we can say is that the sequence converges to negative 1/2. On this example, our sequence general term a sub n is the quantity negative 1 to the n over n factorial. So let's think about this limit as n approaches infinity. So we have negative 1 to the n over n factorial. Now, our denominator is getting really big. So n factorial, the denominator is getting big. And what's happening in the numerator is that piece is making our terms alternate between positive and negative, positive, negative. So overall, what's happening if I graph this discrete function is if I were to substitute in 1, my first term is going to be negative 1 over 1. So I'm going to have at 1, I would have negative 1. And then if I plug in 2, negative 1 squared, that's positive over 2 factorial. So I'm going to have at 2, I'd have positive 1/2. So right about here. And then if I plug in 3, I'm going to have a negative number. So if I plug in 3, I'll have a negative. But 3 factorial is 6. So I'm going to have negative 1/6. So I'm getting pretty close. And then at 4, it's going to be a positive number, because negative 1 to an even power is positive. 4 factorial is 24. So we can see that we are getting closer and closer to 0, but each of the terms is just alternating in sign. But as n approaches infinity, I am getting closer and closer to 0, which is a real number. So this sequence converges to 0. And now let's look at the sequence a sub n equals sine n. So if we take the limit as n approaches infinity of sine n. Now if we think about the continuous function sine of x is bouncing back and forth between +1 and -1. So as a continuous function, the limit as n approaches infinity does not exist. So in a similar manner, if we think about the discrete function, the sequence, which is just going to be specific points that we take at each integer value along the sine function, those two are not going to get close to any one particular number. So since the limit as n approaches infinity did not exist, it's not a real number, we would say that our sequence in this case diverges.